So here we can see the constructional details of junction field effect transistor. So it consists of three terminals. So that is source, drain and gate. So source, the name itself, it says that it can supply charge carriers to the devices. So that means the terminal through which the majority carriers enter into the channel is called source terminal. Simply it is termed as S. And drain, the terminal through which the majority carriers leave from the channel is called as drain terminal. Simply it is called as D. And gate, there are two internally connected heavily doped impurity region to create PN junctions. These impurity regions are called the gate terminal G. So these are all the three terminals available in junction field effect transistor. Then what is channel? The region between the source and drain sandwiched between the two gates is called as channel. So depending upon this channel, the junction field effect transistor can be classified into two categories, that is N channel JFET and P channel JFET. Here we can see the constructional view of JFET. So two internally connected P regions are taken as gate, and in the upper side drain terminal is there, and in the channel lower side source terminal is there, and these terminals are taken to the outside connection through the ohmic contacts. So this is constructional view of JFET, junction field effect transistor. And here we can see the labels of N channel and P channel JFET. So again I am repeating, JFET consists of three terminals, source, gate and drain. Depending upon the channel classification, it is classified into two categories. One is P channel and another one is N channel. Here we can see the symbolic representation of N channel and P channel JFET. In N channel, you can see the gate arrowhead inward, and in P channel the gate arrowhead is outward. So with this symbolic representation we can identify which one is N channel JFET and which one is P channel JFET. And we can compare the JFET analogy with water analogy. So from this diagram we can see that if gate is fully open, the water can flow from source to drain. If we control the gate, that is if you are closing the gate, the water flow from source to drain will be will be reducing, isn't it? So if the gate voltage is the gate is fully closed, then there will not be any water flow from source to drain. So the same way we can explain the JFET operation. Here we can see the operation of JFET. Initially there is no voltage sources given to the JFET, so at that time the channel is fully free, so that the current can flow from drain to source without any disturbance. Now while increasing the supply voltage, the gate will be closing, so that the current flowing from drain to source will be controlled, so that always the electrical analogy will be compared with the water analogy. You can see the operation here. Now I am applying voltage so that the channel is getting reduced, so that the current flowing from channel to, that is current flowing from drain to source will be reducing. Again I am applying voltage, the channel width is getting reduced. So if sufficient voltage is given to the gate, then channel is fully blocked, so that the current flow will be 0. That is, from this case we can understand that if gate is fully open, the current from drain to source will be high. If the gate voltage is given to the JFET, then channel width is getting reduced, due to which the current flowing from the drain to source will be reducing. So that from this category we can, from this explanation we can understand that if the gate to source voltage is going high, then the current from drain to source will be controlled. Hence this device is called as voltage controlled device. That means through gate to source voltage we are controlling the current flowing from drain to source. And here we can see the comparison between FET and BJT. So FET, it is a unipolar device, BJT, it is a bipolar device. Unipolar in the sense the current conduction is due to only one type of charge carriers, either electrons or holes. In BJT, it is a bipolar device. So BJT in the sense bipolar junction transistor. Bipolar, that is the current conduction is due to electrons as well as holes. Hence this device is called bipolar device. And FET is a voltage control device. That means the output current is controlled by input voltage. BJT is a current control device. That is the output current of BJT, that is collector current, is controlled by the input current, that is base current. And in FET the input resistance is very high in the range of mega ohms, and in BJT the input resistance is very low in the range of kilo ohms. And FET is having negative temperature coefficient and BJT is having positive temperature coefficient. And FET will not be suffer by minority charge storage, but in BJT the minority charge storage problems will be there, and it cannot be used for lower switching speed and cutoff frequencies. And FET, it is having less noise and BJT is having more noise. And FET is much simpler to fabricate and BJT is little bit difficult to fabricate as an IC. So this is the these are all the points, the comparison between FET and BJT. Okay, thank you.